Morning, guys. I just wanted to make a quick video for today, talking about today's activity, because I figured there'd be some questions about it, which is understandable. It's math, and I'm not very good at math, so I'm sure that's the same with a few of you. I try to keep it simple, but I know just in itself the equation is kind of confusing to look at, so I wanted to go through a couple of them as examples to kind of get you guys going, and show you how the problems work in different contexts. So we're going to go ahead and do that. I won't do all of them for the sake of time because this would be like a 40-minute video otherwise, and also there'd be no point in having you do it by yourself. So I'm going to try and make this quick and explain this in a way that is short and sweet. So let's do number one first, obviously, just to show you how this is going to work. A population of island birds has settled into a new habitat. Currently, there are only 300 birds on the island. If the carrying capacity of these birds is 20,000 birds and R equals 0.2, how much does the population change per day? And that's what this is measuring, the dn over dt. If you're like me, a big reason why math is confusing is because you don't understand what the variables are meant to show, especially when you get like this d over t stuff, dn over t. So I'm going to try and make this as explicit as possible. I meant to ask that as a question yesterday, and I did, but if you saw my post, apparently somehow the answer box got deleted, so you might not have been able to answer that. So I put all the meanings right here. dn over dt is the estimated rate of change, so like how many organisms are you gaining or losing per day? That's different from the R max. R is the growth rate, so like continuous growth rate is in like over time, and that's based off a percentage. This is based off of an actual number of like how many are you gaining every day. It's a little confusing. That's why I always gave you R, just to keep it simple. So you will never have to solve for R. So if it says the rate, you're looking for the final thing. So the dn over dt. K is the carrying capacity. N is the size of the population. So for this first one, we just have to plug every number in where it goes and run the equation like normal. So we have the carrying capacity, K equals 20,000. And I'll write this down in a second. The population size is currently at 300. And then we have the rate, so we're just going to plug those in and then see what dn over dt equals. So let's see, I'm going to go to paint. R equals what did I say it was? I forget, 0.1. It is 0.2. So for this one, we're going to do 0.2 equals, I keep doing equals, it's not equals, we're multiplying. So K equals the carrying capacity was 20,000. Writing with a mouse is so hard. Sorry if this is not legible. Minus the current population, which is 300. I'm going to rewrite that. Can't write a 3 with a mouse. 300 all over the carrying capacity multiplied by the current population size. Okay, so now what we can do is I can plug this into a calculator, if this will work. Okay, so let's do everything in parentheses first. So 20,000 minus 300, I don't even have to plug that in. I know what that is. That could be 17,000 divided by 20,000 equals this percentage. We're going to multiply that by, it doesn't matter which one you do first. Let's do 300 times 300 equals that times our rate. And that is our answer. So what does this mean? X equals 51, or dn over dt equals 51. That means that there are 51 birds being added to the population every, did I specify? I think it was day. Every day, yep. And you won't have to worry about the time frame because the time frame will always stay consistent. I try to keep it simple for this. So there are 51 birds being added to the population every day. How do I know that that is 51 birds being added? If the number is positive, that is a gain of organisms. If the number was negative, that means that we are losing organisms every day. So that'd mean that I'm losing 51 birds every day and my population is getting smaller, which you'll see in a little bit. So let's do another one. This one will be easier because there's actually a website that goes along with this one, which is why I picked it. I wanted to make it easy. So if it gets confusing, you can just go to this website. So number 3 is the one I want to look at. Where is it? This one. Suppose population of butterflies is growing according to the logistic equation. If the carrying capacity is 500 butterflies and the rate of 0.1 based on month, how many butterflies are added to the population when it's growing at its fastest? So there's a reason I wanted to do this one with you. Where'd it go? Here we go. Here's the question. So if you need help with this, go to this website and they show you how to walk through it. So this problem's on the website. If you need it, they give us all the information we need, but it's worded a little bit differently, so I'm going to show you how to do it. Carrying capacity is 500 butterflies, and the rate is 0.1, and we want to see what is the overall gain of butterflies, what is the dn over dt when it is its biggest. So what is the biggest number we can get for dn over dt? What is the maximum amount of butterflies we can gain at a constant rate? So the way we figured that out, because since they don't give us a specific number, we need to find out what the population size would be at this rate. And the way we'd figure that out is if you look at a logistic graph, not Desmos, just logistic graph, we want to look for the point on the graph where the graph is increasing at the steepest rate. And that is always going to be halfway up the graph, you'll notice. This point here is where the line is the steepest. So halfway up the graph is going to be our maximum rate. So what we do with that information is we know that the carrying capacity is 500, and we know it can't exceed that number. So we're going to go with half of 500 to get our maximum rate, which is going to be 250. That's where they get this 250 from. If you're still confused about that, that's fine. Just do what they do here and plug these in. So 250 is the population size we know when it will be growing the fastest. So we just have to plug that in. Okay, so let's plug and chug. So we're going to do, let me clear this, 250 divided by 500, that's 0.5. We're going to multiply that by the size of the population times 250, was that times our rate, which is 0.1. So 12.5, that is the maximum number that we will get for this set of equations. So 12.5 individuals per month is the maximum amount of individuals you can gain per month. You will never see a bigger number than that for our given set of limitations. If that's confusing, if that doesn't make sense, that's fine. It's not going to be a huge thing moving forward. I just wanted to introduce some variety into the types of questions, and that's also why, if these don't make sense, I included, there's only 2 problems that are worded like this, and they're both from this website, so that way, if you don't understand what I'm saying, and if you don't understand how I'm getting these numbers still, these are on, I'll link this and you'll have access to this, so just copy down what they have. Make sure you show your work though. That's the only way that I'll know that you're like at least trying. Even if you don't understand it, show your work. Okay, so I know I said I was going to do 3 problems with you guys, but I'm actually going to scrap one of them because I realize it's probably going to be more confusing than it's worth, and it's really not important. So I'm going to cut out this one. So that should be fine. I think that's the only problem that would be confusing. The other ones I think you should still be able to do. Yeah, the other ones you should be able to do. So yeah, I'll just get rid of that one. That'll make it a little bit easier. I kept this short. Hopefully it's not too easy, but I didn't want to make it impossible either. So we'll see how this goes today. I kind of left this up in the air so I could make adjustments if I needed to. I don't expect this to take very long, and we can move on tomorrow, but if a lot of people have questions about these and a lot of people are struggling with this, we could make this a 2-day thing. So we'll see how it goes. But either way, today's kind of an introduction. This is the first time we've done practice problems like this, so we'll see how it goes. I'll be lenient, obviously, and we'll get some more practice in as we go. And we'll finish this off tomorrow, either by doing this or doing just some more practice problems, if we need some new ones, meaning you guys finish this one. So either way, do your best with these today. Like I said, I did this one with you. This one's more or less the same. These 2 are on a website, and then you've got these 2, so you should be able to at least get hopefully 4 of them off the bat, and even these are similar to the first 2, so you should be fine. Anyway, do your best. Email me if you have questions. There's a Zoom meeting tomorrow again. Don't forget if you get stuck on any of these, so if this is something that would be better explained face-to-face, feel free to join those. And I think that's it for today. So I'll see you guys tomorrow.